All right. Okay. Yeah, we'll go ahead and get started here. And just like to quick couple of things here. If you can mute yourself, just so we don't have the background interference there. And with kind of number of people on, we shouldn't have issues either with video, unless we'd start getting a whole bunch more people. Then maybe we'll have to turn some video off. But I'm sure Aaron will be happy to look at some faces while he's talking and everything. So again, just appreciate everybody coming out here to listen to this. We've been working on this, what now, Aaron, for, what was it, a year and a half, something like that?
Yeah, about a year.
And really in the works for longer to kind of get a restoration plan going here to get some floodplain and stream bank projects identified up here in the Good Spring Creek watershed. It's definitely not the only one where we need this work, but it's one of the ones where we're going to be starting here. And you know, the hope is with this plan here, you know, it's going to put us into a better position to get grant funding, both public and private, from the you know, sources. So you know, we're gonna we're gonna take it away from here, and once this plan is finalized and approved by NIFWIF, then we're gonna start looking for funding opportunities to keep this moving forward and add these projects to the list we're already working on and we have complete in the watershed. But you know, at this point, I'm gonna turn it over to Dr. Aaron Klauser here, who developed the plan and received the National Fish and Wildlife Foundation grant that funded this project here. So go ahead, Aaron.
All right, sounds great. Thanks, Wayne. I first of all want to thank the Conservation District. They were the sponsor of this grant. So without Wayne pushing for this project to be done, it wouldn't have happened. So thanks to him for trying to bring money into Schuylkill County and actually make the foundation for good things to come to help create better water quality. Essentially, the Good Spring Creek watershed runs from near Good Spring to the town of Tamaqua. So our project area essentially covered the whole watershed. And essentially, there's been a lot of work done throughout that area where you look at mine drainage related stuff and a lot of coal related stuff. But downstream in Tamaqua itself, and as you come down into Pine Grove, there's big issues with flooding and sedimentation. And those aspects have really been overlooked for the most part because of just the fact that the mine drainage was really what was killing everything off in the creek. Before, if there's no fish there, people really have a hard time going after sediment and whatnot. But as the Conservation District and the Watershed Group and concerned citizens have done things to improve the watershed, we've now reached the point where let's see what we can do to sort of take it to the next step. So essentially, this particular plan looks at restoring water quality and reducing flooding. We really didn't focus on the mine drainage stuff. I'm not ignoring that. We're not minimizing that, but we're saying there's other plans that have focused on that. Let's use this plan to look at some of those other aspects of the watershed and sort of prioritize those projects and see what's out there. So with that, we had to secure the funding. We had it's a Chesapeake Bay Technical Assistance Grant from National Fish and Wildlife Foundation. The Conservation District donated some time to the project as well as matching time. So that helped us get this project in motion. The nice thing with this restoration plan is it will allow us to leverage funds, because now that we have identified projects, we'll be able to sort of check off that list of things to do. Then we'll need to secure money for those individual projects, design and implement them, and then eventually evaluate what's working out and try to pass that information along. Overall, in other watersheds I've worked in, that's about a 10-year process from the point where you decide, hey, let's fix up this watershed, to identifying the projects and actually getting them in the ground. So with that, we begin by basically just pulling out the old aerial photography. And this is a shot of the watershed from 1938 to 39. And mouse, there, I'm trying to get my mouse under the other screen. Can you see my mouse or not? I guess not. Essentially, the area of the watershed that you're looking at has all of those little dots in it. And those little dots are actually crop falls, and they're showing that there's a lot of undermining and a lot of abandoned mine areas out in the watershed. And as you move from year to year, by decade or 2 decades in this case, you can see that the watershed overall became more forested, and there was also more development. So as things continued to get forested, mine drainage got cleaned up, but there also was Interstate 81 coming in, and we tried to figure out, what's going on there with that past history of mining. And overall, you can look at the watershed, and we assessed how many square miles there were that were forested versus impervious. So we're looking at each section of the watershed, and we really dove into that in the report, but it's sort of dry information for a presentation. So we're going to talk a little bit more about sort of the restoration planning tonight and where we take this plan and how we get to the next steps. So if you look at the picture in the upper left, that's showing the stream section where essentially the floodplain is disconnected. So there's been sedimentation, or maybe the channel got moved or something like that. And when that happens, the water rushes through the channel very quickly. It erodes the banks, and it basically contains all of that water and doesn't give it a place to sort of spread out and expand. It doesn't have this interconnection with the floodplain to take up nutrients and pollutants. And when you go in to restore the stream, you can pull back the banks and stabilize them. If you look at the left side of the channel, in the bottom picture, they're basically laying it back at a stable slope, so it will not be producing material, not be releasing additional sediment into the stream. If you look at the right side of that bottom photo, we're actually putting in a floodplain bench there, and it's giving the place for the water to go, a place for it to expand into. And in time, it will start to grow up like the picture in the right and return to a stream that is functional and a benefit for water quality downstream and for fish and whatnot that live in that area. So how do you get to that point of doing those projects? Well, what we needed to do was put together a plan that had GPS points, identifying particular locations with particular action items. And then we needed to prioritize those projects, put cost estimates to them, come up with potential partners so that we had people that we could work with in each section, and then also sort of convey the information for each area with a handout to basically provide to the landowner so we could educate people on what we were trying to do. So we did that by completing the desktop review, which you can read more about when you take a look at the plan, but we also did a stream walk. So the stream channel is 6.8 miles long in Good Spring Creek watershed, and Wayne and I and Alexa walked the whole stream channel, and we looked for places we could do things. Also places that were good, and we tried to figure out what can happen at each particular location. So there Wayne and I are walking through the watershed and collecting notes, photos, and GPS coordinates of things to do. And that gave us this restoration plan map. So this is the whole watershed here. If you look on the right side, along the east there, that is the town at the bottom of the watershed. That is Tremont. And then if you look at all those little sort of yellowish colored dots, they have little numbers in them. And those are GPS points where we have something to say about what's going on in the watershed. So if we zoom in more closely at that map, you can get a picture of what these identified projects look like. So if you look at number 14, that's a yellow point. That's a low priority point. So there's something you could do there to fix up the watershed. Maybe it's a small tree planting. Maybe it's something that particular landowner can do. Maybe there's a four-wheeler trail that is washing things into the creek. Then if you look at some of the other sections that are orange, like 19 to 21, that's a project that's more substantial and will have getting on the point of measurable impacts to the creek downstream. And then if you look at section 25 through 32, those are the red projects here, and those are our high priority projects. So tonight I'm going to talk specifically about the high priority projects, and we're going to walk through those, but certainly take a look at the restoration plan. If you look at the plan and you own property along the watershed, or you're familiar with the watershed, it might give you some things to do in your own backyard or nearby. So when you look at those sort of mapped areas, we came up with this prioritized list. And for each of those GPS points, there's a description, there's action items, there's partners and a priority, and then comments on it. So you can basically reference the map and come up with what can be done in those areas, or maybe it's just something to say about a particular spot and what's going on there to say, yes, this section looks pretty good. Wayne and I were surprised when we did the study that there were miles of stream out there that looked really good. But then within the plan, we took the medium and high priority projects and we talked more specifically about those. So here's an example of one of the high priority projects. Within the watershed itself, near Good Spring, there's actually wildcat sewer discharges. So right now today, there are people that flush their toilet and the waste goes right into the stream. So this can be a problem for pathogens, for nutrients. It's just not a real good way to sort of keep your stream in a healthy situation. And it would be a worthwhile thing to seek money to allow those people to put in septic systems or sand mounds, or possibly connect to a sewage treatment system. So there definitely are things that can be done to take care of that. Moving downstream, there are another type of high priority project is a lot more typical. And these are places where there's actually coal silt that is in the watershed, which basically built up the floodplain. So if you look at the photo on the bottom there, you can actually see that black coal silt material or culm. And what we are proposing in many of these areas is to actually come in and remove that material and reconnect the floodplain. That will give the floodwaters a place to go, and it will help minimize this constant sediment coming down the creek and blocking up stream crossings. And more importantly, from a biology standpoint, that fine sediment is a major problem in that it clogs up the bottom of the channel where there's rocks. So if you can picture this beautiful, pristine stream, like in the movie The River Runs Through It or something like that, where there's these boulders and cobbles. What happens with this fine sediment is it sort of, it covers that up. And when it does, there's not this real diverse habitat for mayflies and stoneflies and all of these non-biting insects to live, things that would normally feed in the creek, come out, breed, and then lay eggs back in the creek. But instead it creates basically this wasteland desert bottom that's just sediment. And that's where things like black flies and mosquitoes and things like that, more so black flies, live, because they can't get enough nutrition in this creek itself, so they come out and get a blood meal and things like that. So there's benefits to improving the biology of the stream beyond fishing and recreation and things like that for the people that live along it. So essentially, when you look at a high priority project like this, we would come in and dig down the floodplain, and then sort of stabilize the banks. And then we could also deal with things like these ford crossings that aren't stabilized and are eroding into the creek. So there's things like conveyor belt diversions and water bars that can be done. In many places, planting native vegetation and restoring the floodplain will be a big help as well. Moving downstream, one of the places we came across on our walk had what's called a nick point. So the way streams erode, essentially they start downstream and work their way upstream. So if you think about a waterfall, the power of the stream is creating a scour at the bottom of the waterfall. And over time, that waterfall is working its way backwards upstream. So a lot of times people think that erosion begins at the top end, but in general, the erosion begins at the bottom for how these channels are digging themselves out and digging themselves down. It can be upstream problems causing excessive water flows, but the nick point can really be an inflection point where you need to come in and stabilize it. So we found a nick point where the channel had been diverted and it's working its way upstream. So for a spot like this, we can do things like stabilize it with what's called a cross vein. So essentially we can put in a rock or a log structure that's sort of shaped like this, and you face that into the creek, and the water will roll over that structure and put the energy in the center of the stream, helping to stabilize the outside banks, but also that sort of throat of the cross vein structure in here will actually set grade. So you can step the flow of the creek down in a more gradual fashion and help prevent this largest slug of sediment from coming down the creek. Another area, as we work our way downstream, we found really steep banks, about 15 feet high, that were actively eroding into the creek. And same thing here, basically pull back the floodplain, stabilize it, and plant native vegetation. Sort of a recurring theme in the watershed. One of the major projects in the watershed that currently is under construction is, if you look at the photo, the upper photo in this slide, it's showing the 20 plus foot high banks that are basically waste coal that was placed in the floodplain. And every time you get a storm, the water comes up and erodes the bottom of that coal bank out, and it slides down into the creek and is carried downstream. The material in this particular area is rather unbelievable. The stream segment is 4,900 feet long, and the floodplain has 550,000 cubic yards of material. So Wayne and the folks at the Conservation District are spearheading this restoration, and there's currently $6.6 million being spent to remove that material from the floodplain. If you look at the bottom photo, that's a section where it's really close to done. And basically the restored section is going to have multiple braided channels and grade breaks, and it's a really nice project in that there's going to be a huge amount of flood storage, but also so much less sediment that's coming downstream. And you start wondering, is this really worth it? But when you think about Pine Grove, and Pine Grove had over $40 million of flood damage in the last 15 or 20 years, then soon it makes sense to spend our money on restoring creeks and decreasing flooding coming into town rather than just constantly rebuilding. It sometimes is foolish to constantly be rebuilding the same thing and not taking the time and dealing with some of the problems upstream that are sort of exacerbating it. So if you work your way downstream from that project that's currently under construction, there's a section there where the stream banks are 4 to 5 feet high, and those were probably just built up from coal silt that washed in from that area where the existing project is at. So it would be another place where we could come in and just remove some coal refuse, come back from the stream 30 or 40 feet with a nice floodplain bench, and then plant native vegetation. So for each of these projects, we actually came in and looked at the LiDAR data. So there's actually 2-foot topography throughout Pennsylvania. And we could look at what would make sense to restore the creek and how far to pull them back, what that approximate shape would be. And then I estimated the approximate quantity of material we would remove and come up with a cost estimate for each project. So when you look at the restoration plan, there'll be a photo, and then there'll be this, what's the problem, what's the solution, and approximately how much does it cost, so that municipalities and the county and the conservation district and watershed groups could actually come in here when some funding comes available and basically go to this shopping list of projects and say, well, geez, this project is for $200,000. Can we apply for it? And if you look there probably is a project that'll fit into a variety of funding, whether it's multi-million-dollar or $10,000. There's really a whole variety of projects. As you work your way downstream, this is coming into town. There's a section there where there was actually a flood that filled in the channel itself and started to cause flooding of homes right there at the top of Tremont. And what happened in 2019 is that the municipality needed to get the channel back open to decrease flooding. But what ended up happening is the contractor pushed the material so that it blocked a secondary channel that goes sort of to the west. So to the east of this site, there's an old folks home across the street. And to the west, there's actually this channel that flows through the woods. So this would be a rather inexpensive project to come back in there, pull that material out of the floodplain that's blocking that channel, and allow it to be a place for flood flows to go and sort of divert into the stable forested area rather than into the town. As you work your way down through this stream section, there's also a segment at the bottom of it where the banks are just completely unstable. And you could come in here and put in what's called a rock or a log straight vein. So you would essentially bury a log or a series of rocks, almost like a jetty, but instead of sticking right out in the creek, you basically align it with the stream bank on an angle so that these rocks just roll the water back into the channel. So if you think of a jetty, it sort of juts out and it kicks the water way to the other side. This is more of just a gentle structure that is built into the stream bank and bottom. Floodwaters go right over it. It's low profile, but in the interim on the daily basis, and when you get what's called a channel forming flow, it will cause scour at the tip of it. So you think about stream channels and you look at them and you think, well, they only move in a giant storm. And that's just not true. The bottom of the stream channel moves the most at any point the stream is running bank full. So essentially every 1.6, 1.7 years, we get what's called this channel forming or bank full flow. So a lot of the in-stream structures that we're talking about and specifying in the plan are designed to create unique habitat, whether it's riffles or pools, things like that, that create a diversity of in-stream flow conditions. So if you're a critter that lives in a creek, you don't want to be feeding all the time and you don't want to be resting all of the time. So little things that live in streams generally like a mix. So you need fast, deep water, but also fast, slow water. You need shallow, fast, but also shallow, slow. So a lot of the structures we're specifying create the conditions where the stream bottom will sort of form those different diverse pools and riffles and things like that that wildlife needs. As you come down into town, the problems sort of are all magnified. Basically, there's walls along the creek, but the walls aren't quite high enough when the floodwaters come. And there's bridges across the creek, but if you look at the bridge in this photo and one of the other ones in town, they have a center pier. So there's a lot of things that can be done engineering wise in town. One of them would be to assess whether those bridges could be replaced with a structure that lacks a center pier. The idea is that if you can remove that and redesign the bridge, yes, it will be more expensive, but in a flood condition, you will be less likely to snag trees that are flowing down the creek and things like that to block it up and sort of pump the water out into town. In the plan, I also talk about the opportunity to potentially work with FEMA to buy out some of the houses and create a floodplain in town. So yes, you can keep building the channel up, but the problem is that it's going to constantly be an issue. So over time, the town might want to think about, yes, we might have to sacrifice a portion of the area right along the channel to create some flood additional capacity there, with the understanding that you're protecting the rest of the town. So those are really difficult decisions and really challenging things to look at when you come into a watershed like this. But it definitely is something to consider here. In the plan, I do identify places where there are sort of legacy mining impacts, whether they are from the actual material sitting on the surface, that culm, or if they're places where the deep mines underground are pushing out contaminated water. So the watershed itself is identified as impaired by DEP on there, what's called the 303D list. And all that is a sort of way to count if this stream is good or bad or somewhere in between. And essentially that list is saying that this stream isn't reaching its potential. And the reason it's not, that's identified in that plan, is because of the abandoned mine drainage, both the acidity of the water and also the siltation. So our plan focuses on the siltation, but we definitely are acknowledging that there's a lot to do mine related work as well, which would be reclamation of work. And also an important thing is that we should continue remining areas where there are abandoned deep mines. So if there's abandoned mines there, I'm a strong advocate to come in, remine that area and essentially dig those up, because those mine shafts are allowing oxygen to get down under the surface, which helps to create the sulfuric acid that dissolves heavy metals and things like that and brings them to the surface. And if you can go back and remine some of those areas, which is really difficult with the current economic conditions for mining, but if you can, and I would encourage everyone to support that, when you come back and restore the watershed at the end of the day, 20 or 30 years out, it's a much better situation than having those abandoned underground mines that are going to probably be pushing out water that requires treatment for decades and centuries. So another thing that can happen is, like some of the cogen plants were burning the culm or the waste coal. Yes, it is a greenhouse gas issue, but at the same point, there's a trade-off of it is restoring hundreds of acres where this material is basically sitting there leaching into the watershed. So it's a really difficult decision to sort of have that balance of some of the coal mining and culm pile removal at the end of the day is probably more beneficial than not, which is an interesting trade-off that many people don't think about, but it's going to be difficult to fix up some of the issues in the watershed without mining reclamation. So as we sort of move forward from those real issues and their trade-offs in the watershed, we created a bunch of handouts, and they sort of describe each of the BMPs that are identified in the plan. So there's the mine drainage treatment. The bottom photo there shows one of those cross veins after it's been in and established that sets grade control and helps protect the creek. Stream bank stabilization at the center photo, and then also just some mine reclamation up in the top photo there, and a conveyor belt diversion. If you are out at Swatara Lake at the clubhouse and you walk to the east, you can see where a piece of old conveyor belt has been converted into a erosion control best management practice. So basically, as the water runs down the creek, down the road, it hits this and is diverted into the stable vegetated area along the side. And then for each of those, we essentially have a write-up like this. So I don't want to belabor the point of what the write-up is, but you can sort of take a look at that. And the idea is the conservation district can pass those write-ups on to particular landowners that they're hoping to work with. And then with that, the next step in the project is going to be design and permitting. So each of the projects that we're identifying range from just a tree planting in an area to there's some litter cleanups and things like that that are very small, very straightforward, to actual restoring the creek where we might pull back the banks or create floodplains. Those types of projects will require engineering studies and survey. And then they also will require permits from the Army Corps, the DEP, working with the Historic and Museum Commission and those types of agencies. And with that, we can go to construction and, excuse me, go to construction and hopefully do some projects similar to this, where one side of the creek, there was a historic structure and we were able to come in and put some rocks and stabilize the bottom of the Toa bank there. Got a bunch of native plantings there. But on the opposite side, we were able to pull some material out of the floodplain and create a place for the stream to go, rather than into everyone's homes and things like that. And with that, that is what I have. So I'd appreciate any questions if anyone has them and would like to chat.
Okay, thanks, Aaron. Appreciate you taking the time to, give this presentation here on the important work here in this restoration plan. I think I forgot to mention at the beginning too, that, you have a lot of experience with these types of projects. And for the folks, locally here to the Pine Grove, Tremont area, Aaron was one half of the consultants that designed the Swatara floodplain project there behind Guilford Mills and Pine Grove. So I guess with that being said, if it doesn't work, they can blame you, right? Not me. So
yeah, sure, whatever. It'll work. I'm not worried about it.
Yeah, but
had a big rain get tested.
Yeah, well, hopefully it doesn't get tested anytime soon, but it's a
Yeah.
simple design. The idea is if the floodplain is lower on one side, the water is going to go over there. That's basically our theory. So it's sort of a common sense approach.
But yeah, if anybody has any questions, you can unmute yourself and go ahead and ask any questions. And I think I see there was something in the chat.
I don't see the chat.
Okay, there question is, has an overall conceptual cost been developed for the entire watershed with all wish list items completed?
Yes, there has been. With that, I did not include the low priority projects because, like I said, most of those are things like litter cleanups and a lot of them would be volunteer run and things like that. The total cost, and there's certainly a range there because there's a lot of different ways to design things. And one of the big issues is hauling. Are we going to be able to take this to a very nearby site or is it going to need to go miles and miles away? The range was 7.8 to 11.3 million dollars. Now that would be to complete all of the high and medium priority projects. And when you think, well, geez, $10 million, that's a ton of money. It's important to remember that the conservation district was able to leverage 6.6 million for the existing ongoing projects in the watershed. So it is an attainable number and it is an attainable thing. The important thing is to work on projects one at a time. And there's certainly some projects here that are what you'd consider like a low-hanging fruit project where it's like, yeah, that would make sense, and it's on property that people would want to work on, and it's going to have a huge amount of impact. Let's target those and then sort of work our way down to some of the projects are a little more pie in the sky, long range kind of thing. So I'll admit that, but the idea is let's put them all together and put that list together because it depends on the funding source. Some things you might not be able to do with a particular funding source and other ones you can. So having them all together as funding comes available, you can try to match things up.
Were you, did you have to kind of estimate any savings or reductions in possible like flood damage when you were coming up with these projects?
So in this particular project, we did not create an estimate of the amount of material flowing down the creek or the total amount of flood waters retained versus particular damage to property. No.
Okay. Now, would that be something if you would get if you would start getting funding for the projects, would those types of things have to be then kind of calculated or not necessarily?
So in the plan itself, we talk about how much flood damage there was, but it's rather difficult on a watershed of this size and scale to say, well, this project's going to mean this much, because it's easy to model it if you have a particular storm, but it might rain a ton in this section of the watershed and not over here. Or do we model a 5-inch storm or a 10-inch storm? So
Right.
there are projects that will make a difference, but how much each individual one makes hasn't been modeled. That would be a rather complex modeling exercise that I don't think would make us more likely to get funded.
Okay, thanks.
Okay, any other questions at all?
The coal silt that's been removed that's already like that you're already removing or has been removed. Is that then burned at the local cogen plant, or where does that go?
Wayne, do you want to talk about that in particular for the ongoing project?
Yeah, so it's kind of a two-phased approach there. So if it's burnable and the cogen plant is able to use it, it would go there. If it is kind of such a low BTU quality, and again, that's relative when you're talking about refuse because it's all, has a BTU value of rock, but it would go also to fill in some of the stripping pits locally to get those reclaimed to, essentially eliminate a health and safety hazard and also, create a positive drainage so that water that falls or gets into the pit doesn't get down into the deep mine workings. And hopefully we're keeping clean water clean where it doesn't come out of a downstream mine discharge as polluted water then. So it's kind of site specific, but yeah, the plan is like for the Good Spring project, and it's a relatively small amount would go to the cogen plant. And then the remaining would be to reclaim pits. And again, when I say positive drainage, it's taking into account some type of retention because, obviously those pits have captured a lot of rainfall water and we don't want to just, erroneously put it back into the stream, adding to downstream flooding. But since there has been development since that those pits were kind of dug there, and we don't want to cause issues by doing our reclamation and projects that are supposed to help with flooding. So
Thank you.
Yep. Okay, any other questions at all? I don't see anything else in the chat. I guess if there's no other questions, we can end the meeting here. I appreciate everybody who took their time this evening to come out and listen to this presentation. Just let everybody know we're working. We're all the time identifying, developing, permitting, and constructing and ending projects. It's been this kind of whole effort started right after 2011 there. And, here we are 9 years later and, we had a flood there in 2018. I guess for depending on where you were, you had 2 floods in 2018 here in the Swatara watershed. So, we're working and we're trying. It's just, till you take these projects from start to finish, especially finding funding and money, it can take a while, but, just like the Swatara project, I think we're going to have a real big impact there on flooding, and especially in the north end of Pine Grove there. But, it's one of those where if it never gets used, I'd be perfectly fine with that. That's because we never had the rain again to have to flood Pine Grove. But, the way it's been going, about every 5-6 years, it seems we seem to be getting 100-year flood. So, but hopefully it holds off here, that we can get some more of these projects done. So, again, I appreciate everybody coming out. Aaron, do you have anything else?
I just want to add that the plan is publicly available. I can send it to you by email or WeTransfer if that's too big. If you send me an email, my email is aclauser, so A, then my last name. So it's aclauser@verizon.net. And if you send me an email, I can certainly get you a copy of the plan to look at it. And if you have interest in getting involved, let Wayne know. We're always looking for volunteers for various projects and things like that. So it's a good thing.
Yep.
Thank you.
All right. Thanks, Aaron. Appreciate it. Thanks, everybody, for coming out.
Thank you.
Take care.
Bye-bye.